Hello everybody and happy Science Week. My name is Shanice Griffin and welcome to this careers chat for Science Week. So for this chat we're going to be finding out a lot more about careers in space today, and for those of you that aren't aware, there are currently over 4,000 people employed in Ireland's space industry at the moment, which is incredible, and it's growing more and more by the day. We're building satellites and we are creating lots and lots of space tech. So our little country is doing just fine if you ask me, to be honest. So I'm joined by two very special guests today that are just going to give us more of an insight to their career in this industry. We have Jemima O'Farrell and we have Bas Stynan. Thank you so much for being here. Just to give you a quick insight to their job, Jemima O'Farrell is a researcher at the University of Galway. She began her academic career in astrophysics, but instead of just looking into space, she decided to turn satellite cameras right back around towards our own planet and is currently working on a very exciting project called TAPAS. Now, for those of you that aren't aware what that is, basically it's using satellites and artificial intelligence to help farmers and communities protect their land from climate change. Don't know about you, but I would love to see what that looks like from space, because I'd say it'd be very interesting. So essentially, Jemima's job is to help us understand our world a bit better, protect the environment, and make sure we all have food using cool tools such as AI. And then we have Bas Stynan right beside me. And Bas Stynan is a PhD candidate in mechanical engineering, specialising in space engineering for CubeSats. And if you don't know what they are, basically they are small shoebox-sized satellites that help to explore space. And as well as that, Bas returned to school as a mature student. So he pursued his passion for space and had a short working career, but now he balances his life as a husband, a father, and a farmer. And as well as that, it's all for his exciting research to help make space exploration more accessible. And I find it's so important for you, for those of you that are watching right now, it's so important for you to know that no matter what stage you are at in life, you can pursue whatever passion that you may have. And here we have Jemima O'Farrell and Bas Stynan. Thank you so much for joining us, guys. So we're just going to jump straight into it. Jemima, I'm going to start with yourself. What does your job entail? What do you do?
Right, well, you covered it amazingly. I will say that was a really good overview, but I'll try to give a little more detail. So I work with remote sensing satellites, so they look down at the Earth, like you say, instead of out at space. And there are so many of these spinning around the Earth all the time that we don't even know about, and it's amazing. So the data that we use is mostly optical and mostly looking at crops. So that's kind of what you can see with your eyes. But it also stretches a little bit further out of that range. So we can see in infrared and near infrared and temperature and things like that. So imagine when you're watching those like nature documentaries and they whip out all these other fancy cameras. It's kind of a little bit like that as well. And there's loads of other different types of satellites too. So there's radar satellites, which can zap right through clouds. So you can see the texture on the Earth at all times and detect things like water. And we use all of this to create one big image of the Earth that tells us about how well crops are doing in the face of climate change. So we look at different types of crops and how well they adapt to these big dramatic climate change induced events. So things like floods, droughts, changing temperature, rising ocean levels. And all of this data goes to hopefully making everyone a little bit more resilient to these shocks in the future, and putting in things like irrigation where it's needed, or maybe planting your crops at a slightly different time of the year. And hopefully all of this will down the line create a little bit more food security globally, and help us invest in the right areas so that long term, though we can't turn climate change right around right away, we can all be a little bit safer.
Yeah.
And people, especially in the global south as well, will have a bit more food security, and there won't be huge disasters that will impact people at a local level. So that's kind of the big picture of what I do. And it's dotted in locations all over the world. And yeah, I think it's really exciting. Remote sensing is an incredible, incredible asset. And I think we're only now really seeing how it can be used in so many different ways. So it's really magical stuff. And I think there'll be some examples of the images up on screen as well. So you can see the detail is quite incredible. We look at like fields mostly, and we can detect things like flooding in fields.
Wow.
Urban expansion and all these kinds of things. So there's some wonderful detail about the rice crops in particular here are being flooded when they plant the crops.
That is
So there's so much you
fascinating.
can tell from a
Yeah.
distance, and all just from your little laptop as well. So it's
That is
amazing
incredible.
stuff.
And then I'm going to pass the same question over to yourself, Baz. What do you do? What does your job entail?
Yeah, so like you said, I'm a PhD candidate in UCD in mechanical engineering. Mainly attracted by the prospect of working on AirSat. So to give a bit of background, I studied in the Netherlands in TU Delft, and then I was recruited by the Netherlands Air Force to work on their first military satellite. So I did that for around 5 years. We built the satellite, we operated it, got some really cool things we could do with it. And then I moved to Ireland to work on another first satellite, which is Ireland's first satellite. Yeah, and in the middle of that, I'm trying to get my PhD. I'm trying to be a good father to my son, husband to my wife, and farm the family farm back in Kerry. So it's a lot of like
Balancing out the jobs.
balancing out the jobs.
Yeah.
It's trying to get everything going. My PhD itself, to get a bit more into the science of it, is it's more tailored towards satellite testing. So before they go up and they create the data that you work with, they need to be built, they need to be tested, they need to be tested in a proper way, in the way that they should be operating in space. Of course, that is very difficult to do that on Earth. And with these small satellites, they're cheaper than the bigger satellites. Now, they're not as capable maybe, but they're cheaper, so it's more accessible to people. But they do still need to be tested. It's a very harsh environment space. So I'm basically researching kind of like different ways to test them. Where do we use software? Where do we use hardware? When do we do actual testing, or when can we simulate stuff? And that's challenging. And it's also new for these small satellites to do it in such a vigorous manner, I suppose. So that's kind of like in a nutshell.
It's fascinating though, when you kind of condense it down to what you do. It's fascinating to hear from the both of you. And Baz, I'll pose this question to yourself. For those that are listening and are potentially probably struggling in school, would you say that you have to be good in school in order to do what you do?
So you have to be passionate, you have to be motivated.
Yeah.
You don't have to be top of the class. Honestly, like I was never top of the class. I have dyslexia, so basically throughout my first primary school and secondary school career, kind of was struggling with languages, and the grades were never really up there where they should be. But then to balance it out, I was quite good in math and physics and stuff like this, and chemistry. So it really kind of like, I guess what I would say to the students is like, explore your strengths and hide your weaknesses. And as long as you can do that and do something that you're really passionate about, like I love this stuff, like Star Wars and all the like, the sci-fi things, and that kind of like drew me into a space career. And if you like stuff like that, then don't let anybody hold you back. Go for it and decide what you want to do and where you want to go.
See, I would have been like that, interested in space, in science. Now I would have been brutal at maths in school, but like that, if people have an interest in it and they've motivation behind it, it'll drive you to do what you want to do.
Look at you now.
Oh, no.
You're promoting
Not
space.
too bad.
You're working in space practically as a communicator, so
I'm taking part in it now. I'm part of Ireland's history.
Exactly. You don't have to be, the rocket scientist. We need lawyers.
You just need motivation and drive, and it'll get you far.
Communicate about it, how important it is. We need policymakers. So the space is so multi-diverse.
Yeah, definitely.
Yeah.
And then, obviously, your job entails a lot. Would you say that you need specific skills, or can you learn them over time with the job that you have?
Well, kind of following on from what you were saying, I mean, I had a vast range of grades in school, let's say. So some subjects I really wasn't great at, and that's okay. But I did really enjoy maths and physics. That was something I really found interesting, and I like problem solving. That's just kind of how my brain works. So I think if you have that, a little bit of that in you, a little bit of creative thinking, and like you say, passion, you can build up the skill set quite quickly. And there's amazing resources out there now. So most of what I do is just programming. As a data scientist, I didn't learn a million languages. I learned maybe two at best. And I use those two languages in every day. And yeah, I think if you're anyway good at computers and you have a kind of creative mind, there's many ways you can apply that.
Absolutely.
But like you say as well, you know, you don't have to be just good at the technical aspect. Space jobs aren't just rocket scientists anymore, you know, there's so many different ways.
There's a lot of different pieces to the puzzle, isn't there? Like there's a lot that goes on behind the scene that we wouldn't necessarily know. So it's interesting having this conversation with yourself. And what would your average day look like?
Okay, yeah, so this part I always find quite an interesting contrast because speaking about what I do, it sounds really big. It sounds like a really big scale thing, but we're actually quite a small team and most of us work from home. So I just work from my laptop. I get up in the morning, I get myself ready, and then we have a Zoom call and we kind of just catch up on what everyone's working on, how those things can converge on the project. But yeah, overall, I mostly just work on my laptop from home and I finish around 5 o'clock, 5:30 every day, and I go about the rest of my day. But there is this other aspect of work as well, which is travel, which I love. I think it's amazing to get out there and meet other people in the field. There's nothing like that real experience of hearing other people talk about things that you're passionate about.
Yeah.
You know, the energy in the room is incredible. So I'll often attend conferences. Sometimes I'll be presenting. Sometimes I'll just be absorbing all the ideas in the room and back and forthing with people. So networking is a really important aspect as well. I think people think physicists are very antisocial people, but I promise we're not.
Keep to yourselves, but no, it's the opposite. It's the
I promise
opposite.
we're not. No, these conferences are amazing. So there is a huge aspect of travel and yeah, with the work I do in particular as well, there's often an aspect of getting out into the field yourself and taking ground truth data just so you can connect what you're seeing on the satellite to like a real measurement sometimes as well. So there is a little bit of that, but...
So you're doing really big things from like small remote places in the world.
Yeah,
That's incredible when you really like think about it, isn't it?
It is. The scale of it is quite baffling.
It really
so I just work on a very small laptop and I do connect that to a much bigger computer. But yeah, it's all just on my little laptop and that's most of the work that I do anyway. Yeah.
That's ironic, isn't it though? Like when you think about it.
It is. I think you imagine that it would be a very large scale thing. But no, it's quite a small project, but we do big things and it's amazing.
That is incredible. And then, boss, back to yourself. So you have a farm.
Yes.
What would your average day look like balancing your work life balance?
Yeah, so there's two things. So I work in Dublin sometime. So when I'm up here, it's kind of like, go to university, make long days, be in the lab, do testing and all that sort of stuff. When I'm at home, it's a bit different. Usually get woken up by my 9-month-old son.
The alarm clock of the house.
So after he's sorted out, then it's like you said, behind the computer, whatever, designing things or simulating things or calculating things or making simulations or whatever my PhD needs that day, basically. And then at 4 o'clock, it's laptop closed and wellies on and out into
the mug.
Out into the mug. Yeah, exactly. I'm sure there's people watching that have a farm and they'll know there's always something to do. There's always something that either broke down or a sheep escaped or whatever you need to do, spread something or a shed needs to be mucked out or stuff like that. So there's always something to do.
Always something.
And now recently with my son being born, that adds another layer to all the
other jobs that you have.
Yeah, exactly. So no, it's very busy, very dynamic.
I think so.
But yeah, look, it's nice. It's nice to have different things to do and
you're a man that likes to be kept busy. By the sounds of it.
Exactly. Yeah, that's it. Yeah.
Kept on your toes anyway.
Exactly.
And then back to yourself, Jemima. So with your job, I say you meet all types of people. Would you say that's part of your job that you love?
It is, definitely. It really is. Like I was saying, networking at these conferences and meeting people from all walks of life is always really inspiring, especially when I was growing up. You don't see huge amounts of diversity in physics, but that has changed so much in the last couple of years and it's still changing massively. And I think that's to everyone's benefit. You know, the work that we do can be challenging in many different ways, not just in a technical capacity, but in terms of communication and organization, creative thinking. There's so many different skills involved in some of these projects. So I think when you're closing off the pool of people that you're picking from, you're missing out on some really incredible minds, really driven and inspired people that might think, oh, space jobs just aren't for me. But they're for anyone with the passion. Like, we need these people. Space jobs are being incorporated in so many different businesses now. A lot of people are using remote sensing data from everything, you know, like insurance and bankers. Everyone's using it now. It's become really important. So I think we need as many passionate people as we can get, and everyone's welcome. We need these people in the room having the conversations that need to be had. So yeah, it's something I really love to see, and it's always really heartwarming and really inspiring to see such diversity in the room, and everyone just really passionate about the same thing. It really adds to the energy. It's great stuff.
It does. It sounds like, and obviously I feel like we're all discovering how big of a part Ireland has to play in this, and you wouldn't think of it thinking of how small our country is, but we're like really part of it, and it's so important. And for yourself as well, Baz, Ireland has played probably a massive part of this part of your life specifically. How would you say it's kind of affected it?
So obviously, like with AirSat being Ireland's first satellite, it's massive. Like, I don't think people realize, even though it's a very small satellite, and we'll probably have a picture. It's a small satellite, but it has such a massive impact because it basically, like, so we got ESA funding to launch it, but all the primary elements were built here in Ireland, and we forced the government to change some rules to be able to launch the satellite. So this is how it kind of like it went through the door.
It's powerful, isn't
so
it?
That's kind of like a thing that they didn't like it, of course, because governments don't. But it was massive.
Yeah.
It was really, really big. And then it took a long time. We over 50, 60 students worked on the project, PhD students, master students. And it also engaged a lot of companies. So, you know, like, companies looked at us and they wanted a piece of the pie, or they wanted to help out. They gave us a bit of hardware, or they gave us their skill set, or labs, or and that's really good. And we also collaborated with other universities to do it and to use their test facilities, because we might not have everything. So yeah, I know it was massive, and it was also, for me personally, an attraction point to come to Ireland.
Oh wow!
So, you know, obviously, my wife is Irish, but we were looking to move to Ireland, but coming from a space career background, I was looking for something to do, and AirSat 1 I knew was happening, and I got in touch, and they had a position, and you know, and that
and it all worked out for
and
you.
it all worked out. So no, like, it's a massive impact.
It is,
and
isn't it?
it definitely took off in the last 5 years or so, and more companies getting involved. So no, it's really great, and it's only going bigger.
Yeah, it is. It's only going to get bigger in the next few years, isn't it?
So that's a really great prospect for all the youngsters out there.
Yeah.
That, are inspired by us.
Yeah, no, absolutely. I mean, they're a great inspiration to people, and you probably don't even realize it, but I'm sure there's people out there that are like, I want to be just like Jemima, or I want to be just like Baz, and I suppose that kind of brings us to the next, probably our last question. What advice would you give to people that want to pursue a career in space? I'm going to start with yourself.
What advice would I give? I suppose don't let anybody tell you can't is the biggest thing. You know, believe in your own capabilities and your own motivation. And if there's some aspects that you don't like, just don't do them. Just, you know, do the things that you like, and life becomes easier.
Yeah.
If you do what you like, you'll never work a day in your life.
There you go. That is top-notch advice, that is. And then following the same question to yourself, Jemima, what advice?
I feel like we were going to make very similar points here, but it's so true. Just be really bold about what you apply to. You know, don't underestimate yourself. You're always going to be your worst critic.
Always.
Always.
Is it an Irish thing? I feel like we just can't say
An
compliments.
Irish
either.
thing as well.
Not an Irish thing.
Well, we're very good at giving compliments.
We
we're
are.
very good at
We
taking
can't
it.
receive them. No.
So yeah, just overestimate yourself a little bit and apply for things that you're interested in. Like being interested in your job is invaluable.
I love it.
There's nothing like it. As you say, you'll never work day in your life. If
Yeah.
you find your job interesting, it really makes a difference. I mean, from working non-space jobs in the past, you know, there's a huge difference in your day when you get to wake up and do something you love.
Yeah.
It's really uplifting. So
I
yeah,
love
if you
that.
think you might be interested, just go for it. You know, there's no harm in trying.
Exactly.
There's-
Yeah, only miss out on 100% of the opportunities that you don't take.
Exactly.
Don't just-
Absolutely.
There you go.
Absolutely.
It's a bit of piece of advice for you anyways. But thank you so much. That was very insightful to find out what you work as and what your job entails. So we are going to head on over to you. Basically, you send us in your questions that you'd like to have answered, and we're going to head to a little break. So we'll see you in a few minutes. Welcome back, everybody. So we have questions flooding in, to say the least. So thank you so much for these. But first off, we're going to start with, what did you study in school and what degree did you do after? So I'm going to start with yourself, Bas.
Okay, so my school career was a bit all over the place. So so I started my school career in the Netherlands. Then my parents moved to Belgium and went to like a very regional school. Did some kind of like sciencey things or science subjects, I suppose. But because Belgium is the school system is very different to the Netherlands, although they spoke kind of the same language. So actually, my first school, I was kicked out after 1 year because my grades weren't high enough, although I had all pass grades. Yeah. And then I had to go to boarding school because it was much further away. But there I got the chance to do something that was called industrial sciences.
Wow.
Yeah, so that was really nice. That actually got me the right subjects to go to university. So I was admitted in TU Delft after my secondary school. And TU Delft, I did a bachelor's in aerospace engineering and then a master's in space systems engineering. So that's my kind of like school career in a nutshell.
Wow. Very interesting. And then yourself, Jemima?
Yeah, so I went to school in Ireland and sat the Leaving Cert, and I didn't do as many science subjects as people might assume. I just did physics as my electives. Then I did some other subjects. So I did arts, which weirdly enough, there seems to be a lot of overlap there. I did arts, physics, French against my will, and tech graph, which is like a technical.
Oh, my little
drawing.
brother does that
Yeah,
at school. Yeah.
I really enjoyed that one as well.
Really?
It's very technical. And then I did applied maths outside of school just to really bolster the fact that I was doing French. So I needed an extra
You
one
needed
in
to
there
make up
just
for that.
in case I needed a backup. So then I did a middling enough Leaving Cert, but it was enough to get me into physics in NUIG. And then you do a couple of years and then you go into a specialist stream. So you start off doing broadly speaking physics. So you do a bit of maths, a bit of general physics, a bit of computers stuff as well. And then I specialized in astrophysics, and I did my final project on astrophysics specifically. And I really enjoyed that. Once I got into the research stream, I was flying at that point. And then I got recruited onto this project. And I've been doing that ever since, but I'm sure I'll go back into education at some point and I'll do maybe a master's or something.
That's brilliant.
But yeah.
That is brilliant. So we have another question here. Is there anything that you would recommend for students interested in space to get involved in? So I'll start with yourself for that question.
Okay. So I always did try and seek out as much space-based extracurricular stuff as possible. A bit of programming can never go astray, and there's lots of great free online courses where, and it doesn't have to be boring stuff, you can just like make some games and things like that. But I think getting involved with computers from a young age is really important. It's really helped me. Trying to think. Yeah, and then just get involved with, as you're getting to the end of your secondary school career, maybe get involved with some open days, scope out the different like astrophysics and physics in general departments, and try find a stream that you're interested in. You know, they're really good at making it sound fun and interesting and getting people involved. So yeah, dip your toe a little bit first and see what you think. But I think you'll probably be surprised at what you find.
Yeah, absolutely. And would you have anything to follow on from that?
Well, Christmas is coming up.
Yeah.
So definitely on the Christmas list should be some sort of like Arduino development kit.
Oh yeah, they're amazing.
Yeah, they're absolutely amazing. So an Arduino is basically like it's a credit card sized kind of like processor. And they're really nice kind of development kits online that you can buy. Probably Amazon would be the place to look. But we probably have to now mention all the other vendors online. But they come with different sensors and you can hook them up, and there's like example programming that you can then use, and they're great. Like they're basically like small satellites that you can have on your desk, and you can kind of play around with it. It's really cool. And if you're sick of that, you can join the Irish Radio Amateur Club. They have a small exam, and then you can basically build your own ground station, and you can listen to AirSat, for instance,
Amazing.
from your own back garden. So stuff like that, you can get into the things, start build, experiment.
Yeah,
There you go.
that's very true. Actually, just to follow on from that really quickly as well, from an astrophysics stance and like stars in general, we have amazing skies here. They're so clear. When it's not cloudy, they're very crisp, very clear. So if you can just get out and like crane your neck up at the sky and have a look, there's lots of free apps as well that will tell you what you're looking at. And you don't need a fancy telescope or expensive binoculars either. You can just go out and have a look, and the skies here are beautiful. So if that doesn't inspire you for free.
There you go. And there's another thing to add to your Christmas list if your list isn't already long enough. And what did you need to put a satellite together? That's actually a very interesting
What do you
question.
need?
Yeah.
Oh, first of all, you need a clean space to work in.
Okay.
So we use clean rooms, and so that's very important because you don't want your satellite to be contaminated by any like dust or anything stupid that gets in and prevents it from working. So clean space. You need to be organized. You need to have a set of instructions to do it because it is much more complicated than a piece of IKEA furniture. But you need a very clear set of instructions. So you need to make sure you have those.
No missing bolts. You can't have any missing
No
screws here.
Steady hands. But other than that, a camera to record everything. That's very handy for when you go later on, maybe something went wrong. So if you have recorded everything, everything's there. Other than that, we use screwdrivers like everybody else.
Yeah.
We use
Everyday equipment.
spanners, everyday equipment, exactly. If you have a very clean shed, go for it.
You're sorted. You can build your own satellite. There you go. Learn something new every day. Yeah. And you also mentioned military service. So what did that entail? How was that?
So I was a civil servant
Right.
in the military, so I didn't have a uniform nor a rank. But when I joined, they were setting up their, I suppose the popular term would be Space Force. So they recruited me to kind of like help with that, and then we got some funding to build a satellite, and that's what we did. So we did a study, we got some money, we got a bunch of lawyers, we signed some contracts, and from there on, we kind of like started building up to spec. We had very much like AirSat, we had a couple of payloads on board, a couple of experiments. We tried to do some space weather measurements. So space weather is it happens when the sun interacts with the magnetosphere of the Earth, so the magnetic field actually. And this is what also causes the North Light, the Northern Lights.
No
exactly,
way.
yeah. So that's kind of like high energy particles, kind of like getting all excited and then giving off light. And this interferes with certain radio frequency bands.
Oh. I didn't
So
know that.
a very, I think, famous example is that this happened at some stage, and people from the US, they looked at the radar and they saw all these like weird objects moving on the radar, and they panicked and they thought it was, some foreign nation trying to launch some rockets at them.
Oh God.
Yeah. And after some very panicky phone calls, they figured out that, oh no, sorry, no, it's actually just interference. So from a military perspective, very, very, very important to be able to predict this kind of like phenomenon, so that we know that, for instance, when communication can break out, how we plan certain operations, stuff like this. Another payload that we had was a communication payload. So we wanted to look at, can we, with one small satellite, have our own communication channel and not rely on foreign nation satellites or hired satellites or hired bandwidth or stuff like this. And then we had a bit of a secret payload as well. And can't say much about that, but basically what we're trying to do is to geolocate radars. So it was a bit of an antenna, and we could I suppose, receive radar signals and try and see if we could locate where the radar was.
Wow. Fascinating.
Yeah. So we built that, we launched it. It was a very long project. It was about 4.5 years before we launched it. And then we operated it for a while. And then I moved to Ireland. So I thought, well, did my thing here. You guys are all sorted now. I'll be off.
Brilliant. And Jemima, we actually have a question in for you. So we have, what subjects in Leaving Cert would you recommend undertaking to pursue a career in space-themed opportunities?
Ooh, okay. Wow, that's a fun question. Well, obviously I'm a little biased, but I would say physics definitely. And if applied maths is available to you, your life is going to be a lot easier. But you will cover all of this stuff once you get to university anyway, so I wouldn't worry too much. Yeah, physics was the main one for me. I actually didn't do chemistry or biology, which is kind of unusual, I guess, for people going into such a science-heavy career. I'm not aware of any kind of computer science-based subjects in the Leaving Cert, but it has changed a little bit since I've done it. So if there's anything even extracurricular that you can do in that field, like I say, loads of amazing online courses you can do. So that really helps. But yeah, I think if you enjoy physics and if you have some kind of aptitude for problem solving and maths, then
it's for you.
It's for you.
Right,
yeah, there really isn't a high entryway there. Like, you don't have to do a very specific set of subjects. If you can do physics and then whatever else comes with it, that's great. I mean, like I say, I did art for the Leaving Cert, and that was one of my highest grades. So
same.
Yeah,
I relate with you on that.
There we go.
I didn't do great
It's
in
a
maths,
wonderful
but
subject.
there's other subjects that we thrive with, isn't there?
Yeah, look, creative minds. That's really important too. So.
And I'd say this is going to be our last question, and I'm going to pose this question to the both of you, but I'll start with yourself, Jemima. What would be your dream project to work on? That's actually a very good question.
Oh my gosh, that's a very difficult question. I don't know. That's very difficult. There's lots of really interesting stuff being done at the moment with these things called digital twins. So these are kind of models of different climate scenarios, essentially. So I think it would be really cool to use one of those and predict crop failures under different climate conditions. So let's say we took Ireland, but imagined it was 1 degree hotter. How would everything do? And yeah, I think that could be really useful information for food security and stuff. And I'd also just love the opportunity to work with that kind of data. I think that would be quite cool. Yeah, I guess that's my dream project for now, in the role that I'm in. But I'm not opposed to the idea of going back to astrophysics at some point and looking out at stars again. That's always really beautiful work to be doing.
Yeah,
there's so much to do. Like, there's so much we don't know. So honestly, anything in that field I think would also be fascinating as well.
But and yourself, Pas?
Big rockets.
Oh yeah, I'm with you on that one. So when you do work on that project, will you let me know?
Sure.
I want to be part of that as well.
We'll try
in one way, shape or form. We'll see. We'll plan some.
Yeah.
Well, guys, thank you so much for being here with us today and giving us an insight to your career, and lots and lots of helpful tips there. And thank you guys for tuning in to our incredible guests today. We hope you learned something valuable. And yeah, if you have a passion for anything, doesn't matter what stage you are in life, this is so important. Please never feel like it's too late. Just go for it. All you need, like you were saying, is motivation, drive, passion, and then you're already halfway there. All right. We have a evaluation form link that we would love for you guys to fill out also. But I hope you enjoyed the show that we had for you today. And thank you all so much for tuning in. Happy Science Week.